Okay. So before we went on break in the last class, we continued our discussion on modeling. Right? And the last model we talked about was process modeling. And we looked at different types of process modeling. When you watch the video, you'd find that I also showed BPMN. Right. Now, there are some things I want to clarify about process modeling. I mentioned that people use different names to refer to process models. Let me say process maps, and some may say swim lanes, some may say process models, some may say business process models, and so on, different terminologies. If you study further, if you look into it, you'd find that some people mean slightly different things by these different terminologies. So ideally, process map will be used to refer to the earlier stage of process modeling, the simpler stage where we are just maybe showing the different activities that it takes to carry out a business function or a business process, right? So you are not really looking into details per se. And that's what ideally people mean by process map. But again, ideal is not necessarily reality in terms of how people use these things. So people may refer to it by different names. Don't let that bother you. What I want you to have in mind, though, is that there are different levels to process modeling. Many of you would put process modeling on your CV as something you can do, and justifiably so, right? You have learned it, you are doing an assignment on it now, and hopefully you are successful in your assignment, so you know how to do it, which is great. But there are instances where at least there's one instance that I know of where someone went for an interview and they were, of course, confidently speaking and bragging about their knowledge of process modeling. And an interviewer took interest. Oh, you can do process modeling? Said yes. And I can do BPMN, I can do this. Oh, you can do all that. That's nice. To what level? And they had never heard the term level because they went to, they've gone for normal, this regular type of, they have been barely exposed to these technical things. And so they didn't know that process modeling had levels. Your process models, just like your context diagram. I mentioned before, context diagram, what we call context diagram is actually data flow diagram, level 0 of data flow diagram. There are 3 levels to data flow diagrams. So the one we call context is the level 0, where you are not breaking down the system. So the more you break down the system, the higher the level. That is, the more you show the details of the system, the higher the level. Same for process modeling. For process modeling, you would have typically, depending on the notation, depending on how you are modeling the process. So if you're using activity diagram, or whether you're using swim lanes, or whether you're using BPMN, the number of levels differ. Typically, you have 3 levels, but BPMN, you have 4 levels. 4 levels to process modeling for BPMN. Now, what does this mean? The amount of detail you can put in a process model will depend on the level you want to model it into. And so the level you want to break it down to, and who you are modeling for, right? So who wants to use the model? So a lower level, like a level 1 BPMN model, is good for summaries, right? You are just showing the key activities. Some activities have activities in them, right? Some activities have sub tasks or other activities. So breaking these activities down into subtasks will increase the level. So the more detail, the more level. BPMN, for example, is a full course, or process modeling is a full course on its own. It's beyond what we can cover in this course. So, but I just want you to be aware that it is fine, it is okay to say, I know how to do process modeling. And when they ask to what level, oh, I can go up to level 2 if it's BPMN. But to make claims about other levels, you need to study BPMN even further. So let me see if I can show you an example of what I'm saying. So let me quickly go to draw.io. And look for BPMN. So we have BPMN. I think draw.io does more justice to the different levels than Lucidchart. And what I mean by that is with draw.io, you can begin to see the complexity of BPMN. You see, when it comes to process modeling, BPMN is the gold standard, the highest level. So even just saying that you know BPMN will surprise a lot of people. But I should mention that many organizations, maybe we should say most organizations, will not do any process modeling, not talk of process modeling with BPMN, right? Many places will not require any of these things, right? On the average, a swim lane or using swim lanes is more than enough to represent processes and will be what you would find out there. But in the event that you have to work for an organization that is really, really into modeling and wants you to model with BPMN, it is important to clarify these things. So out of 4 levels, if you say you know 2, you still have tried, right? But if you look at my screen, you can see how draw.io shows the components of BPMN 2.0. And I think we're in 2.5 or something. But this is BPMN 2.0. You can see all these different objects for general BPMN components. Then you go to tasks. So these are the different types of tasks you can have, or these are the different ways you can represent tasks. And that's why BPMN is the highest level of business process modeling. You can write BPMN programs that can lead to automation, that you can test, that you can use to simulate things and see how different processes will perform. Right? So you can use BPMN to simulate processes and say, okay, for example, an airport, what's it called? Flight loading and all those things, right? And people coming off flight. You can model the process and simulate if maybe if we increase this space, if we change something, how will this process go and how will it affect the time or resources? So all those are beyond what a typical business analyst, what a business analyst will be doing, right? Except the person is specializing in process models. But BPMN has that level of power. So the key thing I want you to take away is if you go to an interview and you say, oh, it's on your CV, I know BPMN, and they say what to what level, at least know that there are 4 levels of BPMN. So don't say I know to level 4 or something, right? Or because it's 4 levels, or level 3. In fact, it's safer to say I know BPMN to level 2 because most of your modeling will only get to level 2. What you are doing now in this assignment, the marks you get to expectedly will be level 2, right? So it's safer that way. So two things are key. You know that BPMN or modeling, process modeling has levels. There are levels to them, and that you don't know it to the final level. So someone who, for example, is using BPMN to, again, BPMN is the highest standard of modeling. Most people don't even know anything about it. So these are the different ways you can represent activities. Multi-instance, compensation, and different things, manual processes, business rule, right? So it allows for significant level of specificity. That is, you can be very, very specific in your representation, because the expectation is that what you are modeling may be automated. So when you start getting to those level 3, level 4, the reason why you are going that far is hopefully what you are modeling, it's going to become a simulation representing maybe a system, a process you are trying to redesign. A process you're trying to redesign. So you want to see how things will work and things will change. So that's completely beyond what we're talking about here or in this course. So this is just activities. We have been using this normal rectangle to represent activities, but there are many other ways you can represent different specific types of activities, as you can see. So these are choreographies. This is, again, another aspect of BPMN, and there are multiple ways to do that also. These are events that we have looked at. I've just included start and stop. At a max, you would look at events including wait, for example. So intermediary events like this. So if you want to model, if you want to show that something will take some time to happen, right, and the other entity, the other party or entity will be waiting, you can use this. So rather than start and stop, you can show that maybe the system is waiting or the customer is waiting using this one with star symbol in the middle. But there are several other ways you can represent events. You see, time, you can use these two to show that intermediate. You can use this. So you can use this to show messaging, like a message starts a process, for example, then you can use this. So BPMN allows specificity that you won't find in any of the other process modeling techniques, right? So that's why it's the most advanced. So see all the different ways you can use to represent events, not just start and stop. Then gateways, look at all the different types of gateways you can have, right? So there are levels to it. So as that musician said, when you are going out to talk about this kind of thing, recognize that there are levels, so be humble. So don't be like that, my friend that went for interview and they were asking for, and he was making out about knowing how to do BPM and he said, what level? And he didn't even know that there are levels, not to talk of talking about level, because the person asking just went into the different levels and the different things, and he got stuck there. And you know how that kind of thing can mess you up, where you have gone to open your mouth to brag about something that you don't know the end of. And that's why I'm telling you that there are levels. The maximum you can boast of is level 2. Oh yeah, I can. I've modeled and made sure there are sufficient detail, but just up to level 2. I haven't had the need to go up to level 3 or level 4, but it's something I can learn if we need to. 98% of organizations will never need you to come and be modeling processes, right? This is for organizations specific to process modeling, organizations that are helping other organizations improve their business processes, research and re-engineer their business processes. Most of the time, you won't even be applying to those kind of places. And I don't think that fellow was applying to those kind of places. He just had an interviewer that was very knowledgeable, and he was making too much mouth, and that interviewer caught him there. Right? Okay, do you know this thing? Right. So to be forewarned. Okay. So I wanted us to know that. Now let's get to our business of the day. So our main business of today is class diagrams. And we've been talking about these different levels of modeling or these different types of modeling, different modeling techniques, and what these different modeling techniques bring to the table for us. They show different things. Your mind map shows something entirely different from what your process model will show. And your process model shows something different from what your context diagram will show. And I mentioned to you that this RAD, right, requirement analysis and design specification, and this part of RAD, which is specifying and modeling requirement, is a part of your plane landing process, right? You started from where you did strategy analysis, then you gathered requirements, you elicited requirements, right? You confirm those requirements in the elicitation and collaboration phase. You did all those things. Then you started modeling, and you started modeling from the highest level. Now we're bringing it down. So with class diagram is one of the lowest level of modeling you can do. Class diagrams are easily convertible to codes, to actual codes. In fact, there are some softwares, there are some integrated development environments, IDEs, like Visual Studio, the Visual Studios of the past, and even current full package Visual Studios, where you can model in class diagram, where you can draw class diagrams, and those softwares will convert the class diagram into codes, into programming code, software development codes for you, so that you can develop softwares without writing, without actually writing codes. Okay. So before we start talking about classes and get into details, of what class diagrams mean and how we can model them and what they are used for and all those things, all these lovely things, right? Let's start with the meaning of classes or a class. What is a class? What do we even mean when we say class? A class is a category of things. A category of things. So a class is made up of things. So if you are talking about classes, you are talking about things or entities. A thing, right? So, but because we're talking about information systems, classes will be categories of things that are part of our information system. Right? So because we're talking about technology, IT, right, software, hardware, so things that make up our hardware and software are what we're referring to. So when we're talking about classes, we mean categories of those things that make up our information system: hardware, software, data, people, processes. So a class represents groups of these things. So it's not surprising that when we're talking about classes, we are talking about the things that are nouns in our system. So nouns. A noun is the name of a person, animal, place, or thing, right? A noun is the name of a person, animal, place, or thing. So the nouns in our system are what we represent using class diagrams. Now, we know that things, that classes are just group of things. Things can be animate and inanimate. So they can be humans or living things and non-living things. Things can also be concrete or abstract. Concrete things are things you can touch, tangible. Abstract things are things you can't touch. Things you can't touch. For example, employee performance. You can't touch performance, but it's a thing, it's something, right, that we may need to document in our system, or we may need to keep records of in our database, but you can't touch it. But you can touch employees, they're physical things. You can touch purchased software, for example. So if you have a class of softwares we bought, right, we can call them purchased software. You may be able to touch the CDs. You may not even be able to touch the digital copies, right, if you are buying online versions of software. So you can have that kind of category where you can't touch the things. Purchase hardware, definitely you can touch those, right? So our class diagram helps us represent these things in our system, the things in our system. Like I said, most of these things will have names that are nouns, right? Will be nouns. So our class diagram helps us model the terms that are used in our business. They help us model the terms, nouns, that are used in our business. They help us model the collaboration between classes to implement use cases. And this is interesting. We'll talk about this in detail later. So they help us model the collaboration between classes. Now, let me go back and say, because I said class diagrams represent the things in our system, they help us represent the building block. They are the building block of our systems, right? So what they do is they represent the component of our system, the different things that make up the system we're trying to develop. So class diagrams can help us represent those different things. Okay. So you see, when we are modeling use cases, for example, we'll talk about an entity or an actor and what the actor does. Right? Class diagrams, that use case, class diagrams can help us represent it and show how each actor and what they do relates to other actors and what those other actors do. Right? So, and we'll get to that. You'll see that at work soon. They model the structure of classes and interfaces in the system. They help us reason about the system and how it will work. They provide the basis for implementation in an object-oriented language. And number 5 is the main reason why they are very important and why the key reason why most people would use them. Now, in an agile environment, again, you may never ever need to model at all or even model using class diagrams. But class diagrams are sort of the closest models to programming languages. And so they can provide that basis for implementation using an object-oriented language. You can translate your class diagram to what is called object diagrams or directly to code. So in this case, you have landed your plane. You have written, if you get to this stage of modeling with class diagram, you have written your requirements in such a way that developers can just immediately either take your diagram and generate code from it. So you have done like maybe 50% or 40% of their work, or they can read it and figure out the codes that you want them to generate directly from it. So I've talked about this already. I said some applications, I call them integrated development environments, so IDEs for short, can generate codes from your class diagram. And I've mentioned that programmers can implement your class diagrams. So let's look at the notation of our class diagram. A class diagram is represented by a rectangle with the name of the class at the top. A rectangle with the name of the class at the top. So let me first talk about how we write the names or the class name for a class diagram. So if you are in an environment where you know your class diagram may eventually be implemented as code or be translated into code, then you know that class names in programming does not have space. So if your class name has two words like first name, maybe that's the name of the class, right? A category of people's first names. Right? If this is a variable for coding, then usually it will be written together, it will be concatenated. So you write it together. So there are different ways to do this, to join. So you are joining them together, but there are different ways to do this. You know, I could have written it like as this first name. But the risk in writing it this way is that people may not easily know that this is a different word. So you don't be surprised if somebody looks at this and calls it Farasnamo or something, right? They may call it together because they may not immediately see that you have two different words. So because we are joining two different words together, but we still want to create that separation, that visual separation, there are two ways, at least, that we use. When you are writing class names, the case we use is called Pascal case. And the idea behind Pascal case is every first letter of a word that you are joining together, that you are concatenating together, should start with uppercase. So you'd have first, then the second word, the first letter will start with uppercase, and there will be no space in between. So you join them together that way. First name. And that's how you'd write a class name when you know for sure that the class may be coded, may be converted to programming languages. If you know that you are just modeling just to demonstrate something or to explain something to your developers, you can write them as separate names. Now, some class names would have only one word, like student. So you still follow this rule, which is the first letter of the word should be uppercase. So it will be uppercase. So you don't, it's not a must, it has two words or multiple words. Now, this is not anything difficult. This is just a convention, a way that people do things, right? That people would expect you to do things. So, but if you don't do it, it doesn't make you wrong or anything. Okay. So you can write it separately like this, which is perfectly acceptable. But if your classes are going to be converted into code and you write it like this, you are giving your programmer extra work, because after converting this to code, he has to go and remove these spaces manually. Right. So he has to take another step after converting it to remove these spaces. So you can do it like this. It's even better to put an underscore in between like this, like I've done here, than just not than put a space, because that's additional work. So we use the Pascal's case and you concatenate the words like this. Now, when you are writing the other parts of the class diagram, which will be maybe the attributes of the class or the methods, the operations that the class may perform, you see that on the next slide. You use what is called the camel case. So the camel case, the rule for that is the first letter should be lowercase. So it would be something like first, then the second letter, or any other word. The first letter of any other word you are joining should be uppercase. So you'd have first name, right? So if this was an attribute, okay. So the name of the class should be written, should start with uppercase, but preferably you should use like the Pascal case if you have more than one word and join them together. Now, the other things in the class diagram should start with lowercase, but the next word you are joining, the first letter should be uppercase if you need to join words. So this is how your class would look. The class name on top. Now, if you're just modeling, like I said, separating them like this is perfectly fine. Okay, so the class name on top, the attributes of the class will be next. Then, depending on the level of detail you want to go into for your class diagram, you should be able to, you may not need to include this third component. But this third component will show the operations of the class. Operations, so what this category of things can do. Right? What this category of things can do is what will go here. So what are the attributes of a class? The attributes of a class are the parts of the thing or properties of the things that help you describe this category of things. For example, a person will have some of the properties of a person, right? Will be name. A person will have a name. A person may have date of birth. If he's a person, he should have date of birth. The person may have sex, may have blood type, right? These are attributes. Depending on the system you are developing and what attributes you need. If you are developing a medical or healthcare kind of system, you may need those attributes. Okay, so those are attributes of the person. So properties of a person, or things that help you describe the person are the attributes. Or so moving away from person, you can generalize that to things that help you describe the thing. All right. Then the operations that can be performed by that category of things or that group of things is what we would have here. So in this case, you can get the name of a person, you can set the name of a person, you can find out their birthday. So if the person's name is already recorded in the system, you can get it. If the person's name is not already recorded, you can set it and birthday. If we're doing a class for customer, so we did customer in our use cases, right? So the class name will be customer. What are the attributes of customer? Anyone? Who can tell me the attributes of a customer?
Age can be an attribute,
Okay.
and name can also be an attribute. Birthday can also be an attribute.
Okay. Age, name. All right. Date of birth. Okay. So these are good attributes. Attributes of customer. Now, when you look at your use case diagram, the one we drew in class and even the one you drew yourself, you find that use case diagram does not report anything about attributes, right? It doesn't talk about attributes. It only talks about the thing or the actor, customer, and what the actor can do: withdraw cash. So that's what a customer can do: withdraw cash. A customer may be able to do other things, right? A customer can withdraw cash. A customer may be able to deposit cash, transfer funds, those kind of things. So you can put all those things here. So those will become the things that the customer can do, the operations the customer can carry out. But use cases don't tell you anything about the attributes of the customer. So you see in this box, this rectangle, we already have more information than a use case will provide, because use case is providing another type of information. It's showing you different ways the actors can use the system and the relationship between those ways. But in this case, we're looking at the components. What is the makeup of the system we want to build? And so that for each of those things in our system would also document their properties, their attributes. So things that describe the thing, right? So let's see the different types of relationships that can exist between classes. So we have three types of relationship that can exist between two classes. You can have association relationship, and we have been dealing with association already in our discussions on use cases. We dealt with association relationship extensively. One type of association and relationship that we looked at is just an actor can do something, right? An actor can do something is an association relationship, which was what we looked at in use case. But these other types of relationship we have not looked at, we have not talked about: the aggregation relationship and the composition relationship. Then there are some other aspects of association relationship that is useful in class diagram that provides even more details than what we have done so far. So let's get started looking at the the details of all these different types of relationship. So your association relationship, what that does is to reflect the way two classes relate in the real world. So that's what it attempts to represent. You have two classes. How are they related in the real world? So your association relationship is good at representing that. So it usually represents your association relationship by just a solid line between two classes like this. This solid line is an association relationship. This is not an association relationship. This is an aggregation. You can see the diamond on top and line. But this solid line is an association relationship. So this association name, for example, is owns. And what that tells us is that customer owns ticket. Customer owns ticket. Okay. So these are the kinds of relationship we're already used to. We saw these in use cases. Okay. Now let's see another association relationship that we talked about in use cases. And we call this generalization, but it can also be used to show inheritance. And I explained this when we're talking about use cases. Who can remind us? Does anyone remember? Does anyone remember generalization? Okay, can anyone explain this relationship? Can you explain this model?
Can we say is the extended relationship?
Okay. Anyone else? Anyone else? So the extend relationship does not have this white arrowhead. The extend relationship is a normal arrow. The thing
Okay,
is,
that's my part. Sorry.
yeah, the key thing with extend and include is the dotted arrow rather than a solid line. This is the third type of relationship I explained when we were talking about UML. Said you have three types of association. You have the extend, you have the include, then you have the generalization. I told you that generalization shows a parent-child relationship or can be used to represent a parent-child relationship or inheritance, in fact. So if you are to look at this class diagram, what you have is the class person with properties name, age, size, hair color, and these operations, walk, eat, speak. Right? And you have these two as subclasses or children of the class person. And I mentioned to you that for the inheritance relationship, so you can use this for use cases or any type of, in fact, I used this for one of the use cases we drew where I showed different types of customer transactions, withdraw cash and all that. And I made all of them a sub use case. I made all of them inherit from the use case transactions. I now said transactions can now extend, maybe print receipt, and can include authentication. And since transaction includes authentication, it means all the children, all the withdraw cash use case and all those other use cases automatically includes whatever the parent includes. Because the inheritance relationship, when you see this triangle, this is not a diamond shape because we'll soon get to these open or blank diamonds. which looks like this, but they are different. This is triangle, and I want us to take note of that. Now, the inheritance relationship is saying that the child inherits everything the parent has. So this is the parent. This is child. So the child has every property or operation in this case of use case, right? In this, sorry, not use case, class diagram, we have operations too. So every property and operation that the parent can perform, the child has. The child can also have some operations, some extra operations. So any extra operation the child has, it doesn't mean the parents have it. But everything the parent has, the child has. So the child inherits everything the parent has, but can extend that inheritance, can have more. And that's what you see here. So what this means is the class student is a type of person, so everything on that person is in student. So student will have name, student will have age, student will have size, student will have hair color, which is true, right? Then students will be able to walk, students will be able to eat, students will be able to speak. But the class student, this class student has one extra thing that they have that a normal person may not have, a random person may not have, which is they also have the operation or the method study. So students can study, right? Whereas a person that is not a student will not have to study. So this child class has everything the parent has, but has one more. The teacher is another child class. It has everything this parent, and the parent class is person. So the teacher is a person. So it has all these attributes of the class person, but it also has one operation that the class person doesn't have, which is teach. So this relationship was what I asked you to explain, which is just inheritance. That this class is under here, inherits everything in the main class. So there are subclasses of this person class, and they inherit everything, but they also have some methods that the main class does not have. So let's look at other types of relationships. Now, I said there are three types of relationship for class diagrams: association, aggregation, and composition. So now we're looking at, we're done with association. I've reminded you of the different types of association, which we have discussed before. Now let's look at aggregation and composition. What aggregation means is, or what it denotes is that if you have an aggregation relationship between a class A and a class B, so aggregation will be a diamond symbol and then line, unfilled diamond symbol. So this place is empty, white. What it means is class A knows about class B, but they do not affect each other, which means that class B can exist without class A, right? They don't affect each other. Class A knows about class B, but they do not affect each other. So class B can do whatever it wants without class A. Class B can exist without class A. Now, that's aggregation. And that way you can look at aggregation is just gathering, right? If people gather, right? If people gather now to watch a movie, after the movie, they can go their separate ways, right? So if person A gathers with person B to watch a movie.
Hello, Prof.
Yes.
I have a question. I mean, what you explained and what you wrote here is about aggregation. I did this. You mentioned aggregation composite class B is an integral part of A. Class B cannot exist without class A.
Where are you reading? Sorry.
I'm reading under the aggregation.
Oh
I'm
no.
reading your slide.
Oh, that is another relationship I've not talked about. I said there are three.
Okay. Okay.
Yes.
Okay. Thank you.
Yeah, thanks. So I've not talked about that. That's composition. So still talking about aggregation. What I'm saying is aggregation, you can look at it as gathering, right? If people gather to watch a movie, different strangers just come together to watch a movie, or even footballers come together to play a match. While they are together, they are a team, right? But everyone can go on their separate ways after the match, right? And there will be different people. But together, they're a team. You look at them and say, oh, this Chelsea is stupid. So you see, when you say Chelsea is stupid, you are abusing the whole team. But when they leave, right, they are not Chelsea anymore. Sule is Sule independently. Right? Sule can exist without Chelsea. Okay. Sule may go and become a truck driver if he doesn't want to play for Chelsea anymore. So Sule can exist without Chelsea. And that's aggregation. Aggregation just means gathering. So you are showing a relationship where two things know about each other, two things can work together, they are gathered sort of together, they're aggregated. But the second one, that's the one at the tail end, can exist without the first one. So an example is to look at this relationship. So you have this class for team, and let's call this A, and this class for employee. So the class of employee and the class of team. You see the relationship there is an aggregation relationship. What this means is employees can exist without team. Yes, employees can aggregate together to form a team, right? They can gather to form a team, but employees can exist without team. So if you do away with the team, you still have employees. Okay. So employees can exist without a team. That is aggregation, gathering. Now, the second or the third type of relationship that we'll talk about is composition. Composition, when something is made up of another thing. So class B, if it's composition, and let me show you, which we already have it here anyway, so I don't need to draw it. Class B, so in this case, the diamond is filled for composition. Class B is an integral part of A. So A contains B. B cannot exist or is not useful without A. That's composition. So just the English meaning, compose, contains. Compose means contains. Something composed is composed of something means the other thing is an element, is the constituent, right? So if you say jollof rice is composed, your jollof rice is composed of some things now, chicken and maybe not chicken, the things you use to cook the jollof rice, your oil and all those things. They didn't just gather, right? They have become part of the jollof rice. So composition is where one thing is a part of something else, unlike this one where they are just gathered. For composition, what you are saying is B, this thing that is a part of A, cannot exist without A. But for aggregation, you're saying they are just gathered and B can stand alone. So let's continue with this example first. So for composition, You have team and you have company, right? So a team cannot exist without a company if that team is for the company. So if you have a some of you that have worked in corporate environments, you have a committee or whatever. Those committees can only exist because there's a company, right? If the company closes down, there's no committee. If the company did not exist, there will be no committee, no team, no department, nothing like that, right? So a team cannot exist without a company. So a company can be composed or is composed of team, contains teams. So that's the composition relationship. Now you can see that example. We can use that knowledge to analyze these ones. 1 and 2. So for 1, we have carburetor and car. We can explain the relationship here. Number 1, is this a composition relationship or an aggregation relationship?
So from the class diagram is a composition
Okay,
relationship, and what it means is that the carburetor is a sub part of the car. So it means the carburetor cannot exist without a car. So the
good.
carburetor is just an entity. It cannot function if it's not incorporated to the car.
So the carburetor is useless because the
It's
carburetor
just,
is made for a car, right? So it's
yes.
useless without a car. Okay. So what
Then,
about 2? Someone else?
okay.
That one would be considered aggregation
Okay,
because the pond can exist on its own, and so as the dock. So if the pond is not available, that doesn't mean that the dock is going to go into extension and vice versa.
okay. So we understand the relationships, aggregation and composition. And then we understand the normal relationship of association. So now let's look at multiplicities or cardinality. So people use these 2 words to describe the same thing, either cardinality or multiplicities. Now, because you're using your class diagram to represent the system you are trying to design and to represent it accurately such that it can be converted to programming languages, it is more detailed. So we have what is called multiplicities or cardinality to help us further explain the relationship between 2 classes. So in this case, the types of multiplicities you can have is where you write a number, an exact number. And what that means is, in this case, if we wrote 1, we're saying exactly 1, no more and no less. There's no room for variableness here. If we're writing 1, it means exactly 1. If we're writing 2, it means exactly 2. If it's 100, it means exactly 100. Now, if you put dot dot between 2 numbers, what you're saying is it's either number A or number B. So in this case, if you have 0 dot dot 1, you're saying it's 0 or 1. Asterisk is called wildcard in database lingo, database language. Is used to represent many, means many. So you can have 0 dot dot many, which means 0 or many. You can have 1 dot dot many, which means 1 or many. You can also have something like 1, 2, 4 dot dot many. Who can explain what this would mean? If I had 1, 2, 4, many, what does that mean?
So it means you have 1, okay, 2, 4, and it extends to the white card, which is many.
Okay. What about 3? What about 3?
So 3 has been removed because we started with 1, 2, 4, and after 4 it extends to the white card, which is many.
So what does that mean? If you say 3 has been removed, what does that mean?
Okay. So the white card started from 4.
Yes.
Okay. I have not done programming before.
No, it's fine. You're actually on the right path. I just wanted you to explain some more. Okay. So, like Andrew said, if I take the pain to write out numbers like this, not just one number, not just two, right? I'm writing it out like this. It means I'm trying to emphasize something. If I'm modeling and I write this out as my cardinality, then I'm trying to emphasize something. So just use the same logic. If you look at this one, we said 0.1 means 0 or 1. Then it follows that all these number many means these numbers or many, these numbers or many. But which numbers are these? Remember, I said if you write 1, you mean exactly 1, no more, no less. So if I wrote 1 here, I'm saying it's exactly 1 or exactly 2 or exactly 4 or many, right? And the implicit assumption here is that the implicit assumption here is many means it can only be greater than 4, right? Because 4 is the last number. 3 is missing here, which means that it can never be 3. Because I wrote 1, I wrote 2, I didn't write 3, I jumped to 4. So what I'm saying is it cannot be 3. That's why I took the pain to write this out, that it can be 1, it can be 2, it can't be 3. So it can be 4 or many. So, or numbers greater than 4, but it can never be 3. Now, this may never be the case in reality, but if you were representing a system where they, for example, let's interpret this diagram before I throw that in. This relationship between these two classes tells you that one company can have one or many employees. One or many employees. So is it possible for this company to have 0 employees?
No.
No.
Okay, thank you. Thank you for following. So yeah, it is not possible for this company to have 0 employees because we started from one or many. Now, how will I model a case where maybe by law, maybe let's assume this is not company. Let's say we have this board, let's call it board of directors. And maybe there's a law that says, write it out clearly, a board of directors. And maybe there's a law that says if you want to compose, if you want to form your board, you can never have only 3 employees. You can have 1 person in your board, you can have 2 employees in your board, you can have 4, but it must never be 3. So if I wanted to model that, that's when I will use something like this. 1, 2. So the law says I can do 1, 2, or 4. It should never be 3, so, or many, right? So I can do something like this, telling the programmers that when you are implementing these things, right, a board can never have 3 employees. So when they are registering names of employees, you ask them how many employees you want to register. If they say 3, you say not allowed. Right? The program with the software will say not allowed. Only 1, 2, 4, or many. So if there was that kind of case, that's how you represent it. But at least now we know how to read this relationship and use the cardinality. So one company can have 1 or many employees. So let's see these relationships. I want you to try these out. So who can do number 1? So the nature of the relationship is already explained here, is assigned. So that's what you would use. So who can try?
This one means, sorry, excuse me. This one means that an employee is either assigned a parking space or is not assigned a parking space.
Okay, but what about the cardinality, the multiplicities? You didn't use them at all. You said an employee, which means 1, but
Okay, so it means that 0 employee means no employee, therefore no parking space, and 1 employee means 1 parking space, and that's why it's 1 to 1. So 0 to 0 and 1 to 1, nothing more than that. You cannot assign a parking space to no employee, and you can not assign no employee to a parking space. The same way you cannot assign 1 employee to more than 1 parking space.
Okay, so I want you on the path. I want you to use the words, the relationship that is described here. You used it the first time, right? But you also use the cardinality, right? What does this mean? You can see it here in the previous slide.
0 employee.
This means, can you say it?
Yeah, 0 to 1.
0 or
0.
1. So use it, say it that way.
Oh, okay. Yeah, so no employee.
No, sorry, they didn't say no employee, no here. This is not no.
Okay, so 0 employee means 0 parking space, and 1 employee means 1 parking space. So 0 employee will be assigned 0 parking space, and 1 employee will be assigned 1 parking space.
So that's not what it means at all.
Prof, I think what you want.
Let me try.
What you want to.
Okay,
go on.
Because, and Tosin, I will explain why that's not what it means later, and you will see it. That's why I said use the cardinality and use the language, the relationship they have told you, and map it to the cardinality of the other class. Like just use what you can see.
Prof,
is it the
You
word
are analyzing it.
Is it the word or that he didn't use, like 0 employee or 1 employee? Okay, so if it's 0 employee or 1 employee, is assigned to 0 parking place or 1 parking place.
That is exactly what the model says. And it is important to follow what the model says. And I'll show you why now. So you see, this model says 0 or 1 employee is assigned to 0 or 1 parking place. Simple. That's how to read it. 0 or 1 employee is assigned to 0 or 1 parking space. Now, let me tell you why there's an issue with the analysis, right? If you interpret it as 0 employee cannot have 1 parking space, which is not what this class diagram says, or 1 employee cannot have 0 parking space, which is exactly not, completely not what the model says. You are wrong, because what this model is saying is you may have 0 to 1 employee, 0 or 1, right? And these employees may have 0 or 1 parking space, meaning if you have 1 employee here, it's possible that that employee is not assigned to a parking space. So imagine you have an office in a building. It's possible that the building you have an office does not have parking space. You are the only employee, you are the sole proprietor. Some of you work in places like that where you go and do business in a place, but there's no parking space assigned to you. Maybe you can park anywhere. That's not what we're talking about, but there's no place assigned to you. So it's possible you have 1 employee with no place assigned. That's valid. And it's possible you start a company, the company does not have any employee, but there's a parking space already waiting. Is that not possible?
Yes.
It's possible. So that's why you can't bring your analysis into it. Read the model as 0 or 1 employee is assigned 0 or 1 parking space. You get it? Which means 0 or 1. And that's why this word this or there is carefully crafted. It can be 0, it can be 1. And that 0 employee may be assigned, you can look at it as 0 employee may be assigned 0 parking space, or 0 employee may be assigned 1 parking space. 1 employee may be assigned 0 parking space, or 1 employee may be assigned 1 parking space. My line is too plenty, so it may already be confusing. So 0 employee may go to 0, 0 may go to 1. That's the meaning of or. 1 may go to 0, 1 may go to 1. So 0 employee may be assigned 0 parking space. 1 employee may be assigned 1 parking space. Now, that's not even how you would read it, but that's the meaning of this model. You read it as 0 or 1 employee is assigned 0 or 1 parking place. Now, but for your own understanding, this is what it means. It means this 0 may go to 0 or may go to 1. Now, logically, it's easy for us to assume, 0 will go to 0 only. But that's wrong. That's not what the model is saying. And that's why you should read it as it is. The model is not saying 0 will definitely go to 0. There may be a parking place already waiting. Okay. Now, let's do this one.
Sorry, this second one, that's close to the product. When you have the 1 ... what is that tiny thing that is just, is it 0? Yeah, that stuff there. What is that?
N.
To any number.
N for ninja.
Okay. Can you show me the previous slide? The previous, I want to see if there was N in the other previous slide.
No, there wasn't N.
Yes.
If that's such it. There's no N.
That's why I'm wondering, what is the N doing there?
N
So I'm going to let me try. So
Okay.
that is a mathematics sign.
No,
so
let Winifred try. Let Winifred
Okay.
No, I don't know what it is. That is why I was asking that question, because it's going to be difficult for me to answer.
So
But
that
you
N
know,
is
wait, but you know what this means, right?
Yes.
Replace many with N.
Okay. So one product line contains, sorry, let me see the slide again, please. The previous slide. Product line contains
okay.
one and many now. What does that means many? One or many, sorry. One or many, yes. So one product line contains one or many products.
Okay. One product line contains one or many. But where did you see many though?
You said the N.
I said replace many with N. But you still said many.
Okay. One product line contains one. Okay, one product line contains one or N number of products.
Exactly. So one product line contains one or N products. Okay. So this third one, Tosin, please do this one based on the explanation of the first one.
Zero students register for zero course, and students registers for N course. Zero students registered for N course, and student registered for zero course.
Okay. You're breaking it down though to plenty, but it's fine. You are correct. You are perfectly correct in your analysis of it. But you are not you. So say you were explaining to a stakeholder in a business meeting, right?
Yeah.
And you just had to say it. How would you describe this? So maybe I should
What
go
you have
back.
here is 02.
This is yeah. So this dot dot, ideally, if you are doing mathematics, it will actually be 0 or 02, right?
Yeah.
That's what they taught us in maths, 0 to 1, right? But 0 or 1 in this space, you can look at it as when you're doing set theory, union, for those of us who remember maths ahead. So the union relationship, right? So 0 or 1 still means sort of between those numbers. And that's why 0 or many will still be defined as 0 to many. Right? Now, the key thing I'm trying to bring out is this relationship, this dot dot, rather than breaking it down to 0 students would register for 0 course, which is true, N students will register for N course, which to a large extent is true, but it may not be the, it is true based on the explanation. It's perfectly correct, right? And again, they wrote N, so you are reading it perfectly correctly. But I was hoping you would use the or. Right?
Yeah. So I was just doing the mapping in my head. So I was mapping it as I was talking to you.
You're trying to create the database and see how it will be.
Yeah, so it's 0 students or n students will get 0 course or n course.
Okay, 0 student or n students. You didn't use register. You said
Register
would get.
for, yeah. Register for 0 course or n course.
Okay, so now imagine we are the stakeholders you're explaining to in a management meeting. All of us were tired. We are coming from different meetings, right? And you now show us this model. You won't want to complicate issues by using a different word from what you wrote down that we can see, right? Because then we'll start scratching our head. What is he talking about? Then some people will be forming like they understand. Some people don't understand and they'll just be looking at you that, okay, let him just finish and carry it. Or we'll tell him later that we don't understand anything he has done and he should go and do it again. Right? So you want to be consistent. Since the nature of the relationship as written here is registers for, let's stick with it. Yeah, so we have this 0 or n student registers for 0 n course. So good. Now, if you don't mind, explain the relationship between bank and ATM here. Tosin.
Yeah, I'm with you. I'm looking at it.
Yeah. I just wanted you to know because I didn't mention your name, so you may not know you're the one I'm talking to. Do you remember what this type of relationship means?
Yeah, it's a general relationship.
This is an aggregation, not a general.
Oh.
So do you remember the meaning of
Here,
aggregation? Mm-hmm.
Yeah, I think I do. Okay, so the ATM is part of the bank. The location of an ATM is also a part of the bank, and the identifier, the attributes. Okay, so the attribute of the bank is the code and the address. The attribute of the ATM is location and it's managed by. And then the function of the bank manages and maintains. Okay, yeah, so the ATM location can be at the bank. The address of the ATM can also be at the bank, and the bank manages the ATM, while the ATM identifies and does transactions.
Okay. So who else can explain the relationship between bank and ATM? Who else can try?
So the ATM is part of the bank, and the account is also part of the bank. But the ATM can exist alone without the bank, and the account can exist alone without the bank. Is that correct? Okay,
Let's hear
you
what
just want
Wale
the
has to say.
you just
Yeah.
have you just want the bank
Yes,
and
I just wanted the ATM, but that's fine. That's fine.
okay.
Let's hear
So
what Wale.
let me try again now.
No, it's okay. It's okay. But try. It's fine. Let me see the we're short of time. So go ahead quickly.
Okay, so the ATM is part of the bank, and the ATM can exist without the bank. The ATM can exist alone without being merged with the bank.
Wale.
No, the okay. Sorry.
I don't know if you're trying to confuse Andrew, but I think it's so it's an aggregate relationship between the ATM and the bank. So you can have a bank without the ATM, and you can have the ATM without the bank. But and the location, so the locations does not have to be the same. They can be different locations from the bank and from the ATM, and managed by bias. That is all I understand, to be honest.
Okay.
Yeah.
Laura, can you explain this relationship?
Yeah, the relationship is an aggregate on aggregation relationship. It therefore means that the bank knows about the ATM. The operations can be independent. However, the ATM cannot exist without the bank. Because,
okay.
Yeah.
Go ahead. Because
every input on the ATM must reflect in the bank database.
Okay. So thank you all. I've heard everything everyone said. Now, you see, the first part of what Laura said is exactly what I would have said. Perfect answer. The bank knows about the ATM. The two classes know about each other. But you see, the second part is entirely different. Aggregation relationship means, like I said, you gather people in a team, everybody can go on their separate ways. It's not composition. So aggregation relationship means the ATM can exist without a bank. That's what this relationship means. That the ATM can exist without a bank. Remember, this is a category. This bank class means a category of bank. So, and this is a category of ATMs. So it's possible that this ATM in a particular location can exist without being linked to this particular bank. Let's call it Bank A, ATM A. That's one way to look at it. I don't know if they are common here in Nigeria, but I know, for example, that stores here run ATMs, right? ATMs don't necessarily have to be linked to one specific bank. They can be putting cash there for people to withdraw and running it that way. So this is saying that the ATM can exist without the bank, but there's a relationship between them where both are aware of each other, so they are aggregated, right? But ATMs can exist without a bank. That's what this relationship represents. Composition is the one that says B cannot exist without A. So in that case, Laura's answer was near perfect. Same with Andrew's answer. Near perfect. I think the first part of the explanation, I can't remember how Andrew explained it, but the first part was needed a bit of smoothing. So Wale was like, am I trying to confuse Andrew? Well, I wanted everyone to get a chance to answer the question. Now, these other things, these properties, like I mentioned to you, they are attributes of the class. They are attributes of the thing. So they tell us more about the thing. So an ATM will have location, will have where it is managed. It doesn't have these are properties of ATM. It doesn't have anything to do with the bank. And so I think Wale, I heard some of us trying to connect the attributes of the ATM with the attributes of the bank. They are two different entities. They are two different entities, two different things. The only thing that joins them together is this relationship. And that's why this line is there to tell us the type of relationship that exists between them. A type of relationship in an aggregation relationship is that we have mutual respect. We know we know each other exists. We can work with each other, but we can also go our separate ways. Is it possible for a bank to exist that does not have ATM? Yes, you can have a bank that does not have any ATM. At the same time, you can have an ATM that is not based on a bank. Like that is not owned by any bank, right? It's not part of a bank. What he needs to do is connect with maybe a switching organization or one middleman, and those middlemen, middle interface system will connect to different bank accounts and carry out the transaction. It doesn't need to be owned by a bank. So in that case, you can have your ATM at home and be using it. Some rich people have that here. Private ATM in your own premises, not owned by any bank. Okay, so that's the meaning of this relationship. Right? You can't take the property of this class and be using it to explain another class. They are not, properties don't have anything to do with each other. Properties tell us more about this thing. The thing is inside. Okay? The only thing that tells us about relationship is the type of line. So that's fine. So Andrew explained account already. Right. Andrew explained account already and the relationship between bank and account. Now, let me ask a question. How many types of account do we have in this model?
Two.
Andrew, what do you think?
Proof, I'm still thinking.
So I'll come back to you. Tosin, what do you think?
Two.
Wale, what do you think?
Two, savings and current.
So the classes of account we have here, there are two. Winifred, what do you think?
Two.
Andrew,
Proof.
are you ready now?
Yeah, we have two accounts. The parent is account and the child are current and the savings account.
Okay. So that's correct. We have two types of account, current and savings. Good. So we understand this relationship then. All right. This is inheritance relationship showing that current account inherits from the class account, savings account inherits from the class account. So we don't need to repeat the properties of account. Your current account will definitely have account number. That's why there's inheritance, saying everything here is inherited by the children. So that's what this relationship means, inheritance or generalization. Okay. And then the current account can have some things that the savings account cannot. So the expectation is that you withdraw from your current account, but hopefully you will not need to withdraw from your savings. That's not reality, but there's that expectation. Okay. How are we doing for time? So let's use the remainder of our time to look at, this will be very quick and easy because we have learned class diagram. There's another type of modeling technique called entity relationship diagram. The goal of entity relationship diagram is extremely similar to class diagram. The same notation, similar box, everything is the same or similar. But ERDs are used to model the structure of our database. Structure of databases or structure of data, if you want. So structure is also called schema. So if you want to be technical, if you want to sound like you know databases very well, you can say, I use ERD to model the schema. It just means the structure of my database. So class diagrams will be used to model the structure of your program, your software. But the database part, ideally you would use ERD, entity relationship diagram. Entity relationship diagram started before class diagrams. So class diagrams look extremely similar. Some people would just use class diagram to model ERD. They would use class diagram to model their database schemas. So it's the same thing. Now, there are some, and I will show you funny ways ARD represent cardinality. You can represent it exactly as I've shown you in class diagram, or you can use what is called crowfoot, and I'll show you now. But the key difference between class diagram and ERD is ERD has or focuses on just the two components, the name part and the properties or attributes. So nothing about methods and all those things, nothing about methods or functions, right? So it's just name and attributes. Now, out of those attributes, some of them will be keys, primary key and foreign key. If you are used to database lingo, you understand what I'm talking about already. So it's just like your exact class diagram, but the difference is no methods or operation section, and the attributes, one of them will be keys. So if you had a class student, the attributes of the student will be age, date of birth, etc., right? Course, all that. Now, what you mean by representing an entity student or class student like this is you can convert these to a database table. So you will now, your table, each of these boxes will represent a table. Your table will be student table. That student table will now have field names. You see these properties, these attributes will now be the field name. So let's put ID, for example. So that means the student has ID. Then there'll be age, there'll be day, there'll be date of birth. So these attributes in the box, when you are creating your database and you create a table student, you convert these attributes to field names. So these attributes are field names. So for ERD, you can specify one of them as key, as primary key. one or more of them as primary key. And if you have a foreign key there, you can specify. So if we say ID is the primary key, it means ID is what we would use to search for the student. ID is going to be unique in this database. So no two students can have the same ID. Okay. So entity relationship diagram is used to represent the structure of databases. Unlike class diagrams, that is mainly used to represent the structure of your code, your programs. So cardinality in ARD is or used to be represented this way, and some people still use it. This is called crowfoot. Crow, that bird. Crowfoot notation. So this means one. This is many. This is one and only one. This is 0 or 1, 0 or many. Now you don't need to memorize this if you need to draw it. Most of the drawing tools will not even use crowfoot. Most of the drawing tools will use this notation we are using. You see all this cardinality for class diagram. Even when you tell them ERD, that's what most people use now. Most people don't use this crowfoot anymore, but they are representing the same thing. You see all the cardinality we talked about in what's it called in class diagram is the same cardinality that is being represented here. It's just using some funny symbols. This is why it's called crowfoot, because it looks like the feet of a crow. Right. So this is our asterisk now, but it's represented this way. This is one, but it's emphasizing it one and only one. 0 or 1, 0, one or many, 0 or many. So it's not too complicated. It's not too difficult to remember. The circle is 0. The crowfoot itself is many. This is 1. This is many. 0, 1, 1 and 1. So 1 by force, 1 and only 1. Then this is many. So it's not difficult, but most times, most software don't use it anymore. So you may not find this, which is fine. But that's the key thing with entity relationship diagram is exactly the same thing we were doing. So this is how an entity relationship diagram will look like. You have the name of the class or the entity, savings, withdrawals, reports, transaction type, client. Then you have the properties or the attributes inside. Then you can declare some of the attributes as primary key. So meaning they'll be unique, right? So no two balance inquiries will have the same balance ID. Each of them must have unique balance ID. No two clients will have the same client ID, which makes sense, right? In an ATM or in a bank, no two customer should have the same customer ID. Everybody will have different customer ID or different account number. So transaction ID will be unique. So you may make that a primary key, which is the case here. Right. Then foreign key, I'm not teaching you databases. That's beyond the scope of this course. Some of you already know database. Foreign key is just a primary key in another table. So all these will now be tables. All these will be tables because you are using this symbol, this modeling to represent the tables in your databases. A database is made up of one or more tables. So you're using this to represent the tables in your database and the relationship between them. So it's exactly like class diagram. The key difference is you can declare some attributes as primary key and some as foreign key. Every other thing, you can use the symbols, the exact symbols you're using for class diagram to represent them. Okay? Any question? Any question?
Yeah, Prof, you just taught us a lot of diagram. So the application of them, that is applying them to real life and when to apply them to real life. I think that is going to be the challenge.
So okay,
in
go
real
on.
life, in real life, when do you use the process diagram, use the class diagram, or the entity relationship diagram, or you use like the data flow diagram? And so there are a lot of diagram, the contextual diagram.
Okay. Yes, so you are correct. There are a lot of modeling techniques, and I can assure you this is the last one we are doing. Okay, so no more.
No, I want to know.
Yes, I understand, and I'm coming. I'll answer your question. So when do you use entity relationship diagram? Right. If you are representing a database, entity relationship diagram will be your go-to if you are representing the structure of a database. Okay. So like I mentioned, you can use your exact class diagram, but you should know, and I think I should be able to, I can show you. Let me see if I can go to one of these
So
diagram
this
tools.
entity relationship diagram,
Yes.
would we use it for like that our assignment number 2 where we have hostel, something like that?
Assignment number 2, you had hostel. Were
Yes.
you required to design a database?
No, I'm saying you said you would use it for database.
Yes.
In that assignment, it has to do with like students' database and all that.
Yeah. So if you are tasked with designing a database, that would not be a common task, right? But for some reason, maybe they want you to work with the database people. We don't know what organization you end up working for, right? They want you to work with the database people, and they want you to represent the structure of the database you want them to design. You should know you are using something like a class diagram. So entity relationship diagram is ideal in that case. And
okay,
the key thing they'll be looking for, right? The good thing with entity relationship diagram and class diagram is they are real implementation diagrams. I don't have access on this computer but I could show you. You would see that databases or database management systems like Access, for example, generates these things automatically. As you are creating a table or creating multiple tables and creating field names, is generating entity relationship diagram. That is how it understands your tables. It understands them as this entity. So if you create a table for savings, it will create a box for savings. If you put field names like, okay, it's the savings in your table, there's a column for saving ID or save ID, there's a column for client ID, it will be representing exactly like this inside in one part of Access, right? So that's the beauty of these two modeling languages we just talked about, which are very related: class diagram and entity relationship diagram, right? Which are extremely similar. They are the closest to implementation. Like raw systems can be developed with them. To your question, if you are asked to develop something you are working with database people and you need to model something, what the database people will be looking for from you is, say they are working on a school system. What are the things, what are the entities, what are the classes that they should create tables for? Right? What are the classes you want to collect data about? So you see your use case diagram, for example, where you drew the actors. Those actors are some of the entities that you would need to collect data about. So you will now look at your requirements. What are the things that your stakeholders have told you, right? About what are you definitely you have more information in this case than the database people. That's why they will, if they ever ask you to do this kind of thing, that's the only reason why they will ask you. And I'm using a school example. It may be anything, right? So you have collected requirements. Your stakeholders would have told you the different things they want data about. That is the business people. Now, they have told you the different things they want to collect data about and the kinds of data they want to store. So what the database people will now be requiring from you is that you help them, you tell them, right? You communicate that to them using a model like this. So this one is an ATM management system. Let's assume that I don't know anything about ATM. So I've met stakeholders, I've met bank, I've met all those and the technology companies and the different stakeholders involved. And I've gone to ask them, so what kind of information will we need to keep record of? What are the different parts of the ATM? What will we need to keep record of? Yeah, we'll need to keep a record of the person's balance. We need to keep a record of the person's card. We need to keep a record of the customer themselves, right? The customer is coming to use the ATM.
Okay.
We want to know who the customer is or client, their name, their this and that. They will tell you all those things. So those are the things you are representing in your diagram. Those are the things you are representing in this model. Right? So the customer of the ATM, your stakeholders will tell you what they need about the customer because you can't just assume, you don't know. Do you need the age of the customer? They say yes. So you are just representing what they need about the customer. What else do you need? What other information do you want to collect? Okay, the customer will use a card. We want the ID of the card and the type of the card. So you represent that. The customer will perform transactions. We want to keep all records of transactions. Because there are different types of transactions, savings and whatever. Do you need to keep that? They say, yes, we want to know the type of transactions the customer performed. Then you have transaction type. So it depends on what they say, right? And that's what you model. You model it using these boxes. If you are keeping withdrawal, what information do you need about the withdrawal? Oh, we want to know how much was withdrawn, right? And who withdrew it. What about savings? If a customer comes to use the ATM to deposit money into savings, what do you want to know? You want to know the customer that saved the money. You want to know the account that they save the money in, and we want to know the amount. And that's what you are doing. So it depends on the requirements you collect. Okay, it depends on the requirements you collect. Now, this will be easy for someone who has this, for example, ERD will be easier for someone who has maybe knowledge of database. Right? Knowledge of database, you already have, even if it's superficial knowledge of database, if it's not even deep knowledge, you don't need to know SQL, structured query language, or any of those things. Maybe you know access, right? And you can connect tables together. Then this will be easier for that kind of person. But if you are not familiar with databases and you are thrown in this kind of situation, which I doubt, right? I sincerely doubt that anyone will. But there's nothing that is impossible. Your organization wants you to model ERD. Yeah, then you have to find a way. You try, you make an attempt. Part of, and we'll talk about this next. You see the tips and tricks that business analysts use to ensure that their modeling is correct, right? So, but, and I'm going on forever here. To Andrew's question, how do you know what model to use? Many times they would tell you. Many times you'll be told what you need to do. Okay, so if you, let me see, what modeling do we have here? If your organization wants you to model use case, they will tell you, whoever is your line manager will say, they will use the word use case. We want you to represent the use cases of this system. You have, oh, have you collected requirements? Yes. Could you please could you please show us the use cases? Right? Or model the use cases. They will tell you what they want you to do. Nobody is expecting that you would just figure it out. Okay. And if they want you to model for a database, they will say, oh, we want you to go and work with the database people. Can you model the schema, the structure of the database? Right. Class diagram, if they want it, they will tell you, can you model class diagram? Right. So it will be specified. No one is expecting that you just figure it out, because you may use something different.
I have a question.
Yes.
Okay.
You said they will tell you. Is it the organization you're working with? They will tell you.
Yeah, the person giving you the task. Someone is giving you a task. It may be your product manager, whoever, right? Someone, the task is coming from somewhere, so they will tell you.
Okay,
except you are the, maybe you get a job where you are the chief BA, and I say that tongue in cheek, jokingly, but you may be the only person in the organization, which is good and bad, right? It's good in the sense that nobody will, you may be the only business analyst, the only one who knows anything about business analysis. So nobody to tell you anything. So you have to figure out what to do. Right? That means whatever you do is what they will accept, because nobody knows business analysis. Nobody can judge whether your work is good or not. Right? So there are 1,000,000,001 organizations out there. We don't know which one you end up with. But ideally, in a structured organization, if they are giving you work, they will tell you, oh, please, right, we need user stories for this. We want to communicate it to development. We need use case diagrams so that we can document this thing. We need entity relationship diagrams because the database people, in many cases, you may never ever meet any database person. You may never ever have anything to do with them. Right? You may never ever, all this entity, this thing, this may be the last time you will hear of it in your life for some of you. Right? But we don't know where you will end up. So that's why we're talking about these things broadly. Right? That's why we're talking about these things broadly. And we'll continue to talk. This is just one part. This is just, although we have ended this part and we've gone into details about it, but this is just one part of RAD. This is specify model requirements. The next part is verify your requirements, which is what we'll be talking about tomorrow. Verify your requirements in summary, maybe we can even just finish it today, is show another BA what you have modeled so that they can correct you. Okay, so they give you work. You should look for somebody, another BA that you know, as long as you don't violate your company's policy. So if it's top secret work, you have to guard yourself, right? Don't go and do anything that will make you lose your job. But if there's a BA within the organization that can look at your model and tell you if your modeling is correct, or if there's somebody external that you trust, right? That you can say, okay, they say we should model this entity relationship diagram. Or this database structure. I've started it. This is what they want us. I collected requirement. This is what they want from us, but I'm not sure if I'm getting it. And the person can quickly help you straighten it out. That's part of RAD. That is the ideal step, no matter who you are, right? Based on IBA standard. That after you model, you show a senior BA or somebody else, right, to help you look at your modeling to make sure it's correct. So it's part of the process. Nobody's expecting you to go it alone. I hope that helps. So I've answered two things. You'll be told what to do, and it's not expected that you do it alone.
Sorry, please, what tool? Is it the same tools that I use for this ERG? Do we see these relationships in maybe like Draw.ai, or the company will have specific tools?
So I'm not sure I understand the question.
No, I'm asking if I want to draw maybe this schema relationship.
Yes.
Is it, for example, the Draw.ai?
Yes, yes, of course. Any modeling is modeling. You use a modeling tool. Yes. The same way class diagram is on Draw.io, Lucy Chart, all those things. ERD is there. The same thing. Like I said, you can use your class diagram to do the exact same thing. Most of those modeling tools, they give you the same components for both of them because the same thing. Okay. So I don't expect, but I won't be surprised if, for example, one company, any company that is doing modeling, maybe serious about modeling, they involve a lot of modeling in their stuff. Now those companies are becoming fewer and fewer because most people have switched to Agile. But if that's the case, I can't predict what tool they will be using. But to me, that is not something to even think about or worry about. It doesn't matter, right? To me, in my own mind, it doesn't matter. And I don't know why it should matter to you. But that's my own thinking from where I'm sitting, right? I don't know why it should matter to you. It's just like saying, oh, our company may be using Lucy Chat, oh, and our own company is using Draw.io. Does it matter? The question is, can I do the drawing? The tool does not matter. Right? If you don't know how to do the drawing, even if they give you a tool that is speaking your native tongue, you still don't know how to do it. Right? The tool, the software is designed to be easy for you to draw. Anybody can use it to draw. The question is, do you know what to draw? So the tool should not matter. Just like say, oh, these people are giving me 2B pencil. This one is giving me, no, that's even, I know in the olden days, we used to have Eleganza and Bic. So this one is giving me Bic. This one is giving me Eleganza. Does it matter? The thing is, regardless of the type of biro you are using, do you know the answer to the question? Why are we asking about biro, the brand? It doesn't matter. It's like inconsequential. Does not matter in any way. If you don't know the answer of the question, if you like, we should give you the sharpest biro in the world. You don't know the answer, you don't know the answer.
Prof, you know, one thing is that we are still learning. So
I understand.
Some things that doesn't matter, we may bring it up. So
no. I completely understand. And that's why I'm that's why I'm using this analogy so that hopefully we can all understand the way these things work, that the software, Draw.io, is someone developing it. Lucy Chat, they are developing it. All of them are developing it so that Draw.io is free because I think Google or somebody is paying for it or whatever. But Lucy Chat is for sale. They develop this thing for everybody to use, right? So the easier it is to use, the better for them. They don't know what you use it for. And they don't care. They're just looking at how can they make it easy for you to draw models. Now, the question is, can you model? If you can't model, no matter what they do on it, you still can't model. Because they are not the ones that will tell you what class name you should use, because they don't know anything about what you are working on. They are not the one that will tell you what the primary key should be, because they don't know anything about it. Or if you are using or what's it called, mind map, they don't know what your stuff should contain. So that's why I'm saying let's not worry about what tool. Doesn't matter. It's the same as saying what brand of biro. Doesn't matter. That is their job. They're trying to replicate like brand of biro. Your company may be using Visio. What does that do? It doesn't do anything. The question is, can I do the modeling? It doesn't matter. I hope that helped. Laura.
Yes, Prof.
Yeah, it does.
Okay. Okay. Yeah. So feel free, play with these different types of biros you have, right? Lucy chat, play, they are there free. Play with them and see if there's anything that stands out. But playing with them doesn't help you know how to model. It does not in any way. So because they are just biros. Okay. Yeah, so that's that. The next thing we'll be talking about, we'll continue tomorrow, is verify requirements. Right. And that we've already mentioned the key thing there, have someone else check your work. So don't be afraid, don't be bothered about all these things. Focus on which of these modeling techniques have you learned, the assignment you have you actually done it? Have you practiced this modeling technique? Have you used any of the software tools? Like I said, get into them. Don't be afraid to use a tool that someone is designing to make life easy for you. So use them to try and create these models. Some of you that have created yours on paper, try them out on the software and do that. So you get familiar with these modeling techniques because they will go to on your CV. And these are some of the things the companies want to see, even if they may never ask you to do them. But just seeing that you can do them for some people gives them that sense of, okay, this person knows business analysis. Okay. And who knows, you may end up in an organization where they want you to do them. And as long as they are paying you well enough, why not? Right? Why not? You get it done. You practice more and you get it done. Okay. So don't let these things worry you or trouble you. Okay. In case you are worried, don't be worried. In case you are afraid, don't be afraid. Okay. We have overspent our, today we use, so we spent so much time. I didn't even, let me stop this.